Alright, everyone. And we are going to be picking we're going to be going back through some more of these 75, Leetcode 75. Can place flowers. I have no idea. Feeling a little groggy today, so we're going to go ahead and we're going to start with an easy one today. So, all right, bed of flowers list and int. Okay, you have a long flower bed in which some of the plots are planted and some are not. Wait a minute. You have a long flower bed. Oh, okay. However, flowers can't be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where a 0 means empty and 1 means not empty, and an integer n, return true if n number of flowers can be planted in flower bed without violating the non-adjacent rule, and false otherwise. All right. Let's go ahead and get started. Here we are. So I guess my first question would be, let's get this over here. Still didn't. And let's let everybody know at everyone I'm live. There we go. Boom. Shakalaka. Don't have Anaconda. I went back and forth yesterday. Man, the other hard drive, I just decided to run errands while I was waiting on that one to come back up. And no, so much faster than the other hard drive. All right, I hope everyone's doing well today. We'll go ahead and just keep plugging along on this. No, there. So we can experiment. Let's just copy this over. One, two, three. All right. This is true and this is false. So let's go back and look at, let's copy this, reread this. All right. You have a long, so an integer array, so it contains n 0, 0, 3, an integer true if n flowers can be planted in the flower bed without violating. What's the rule? Flowers can't be planted adjacent to each other. So all right. First, I thought I had this. So basically, all right. However, some are not. So this is a long, I'm trying to visualize this. If n flowers can be planted in the flower bed. Got it. Okay. All right. Here we go. paint and snippet. Let's get snippet too. Don't need this right now, but here we are with the paint. So let me show you. All right, so copy this. Paste. That's interesting. That remembers the last size we put it on. There we are. All right. Brush. So here we are with, this is what I envision. And this is 1, 1, 0, 0, 0. Now they're not allowed to be next to each other. And we want to add 1. So we can put 1 flower bed here. Now, the second one is 2 flower beds. And this is in violation because we can only add 1 more here because we have to have a boundary of flower beds. So, all right. Now, we need to solve this, and we need to see if we can solve this in the most efficient manner yet. Probably gonna have to cut short today because I got a dentist appointment and I got to do my regular stuff, get out of here, and then go. So just to let everyone know, probably be an hour and a half, maybe. Nowhere near 2 hours. All right. I don't know, the lights seem really bright today. So how in the world are we going to go through here? I can't tell if I have something growing in my finger, like a blister, like a callus, or it feels like a splinter, but I don't see anything. All right. So because I really don't want to iterate through this twice. Basically, all right, could we change this and come up with the pattern? Because, all right, so here's what I was saying, go through this twice. So if we get a 1, we just need to find 3. Ooh. I feel like we have the math on this. So if it's 1, I need 3 planters, 3 empty planters. If I have 2, I need 5 empty planters. If I have, now on the ends, could this change? Could this change it? But this is going to be, I would need, because we need to have, want to try something. Peaky, how are you? I'm doing well. Glad to have you here today. So we're working on some more. We're on day 2, going through all the 75, and it said give yourself a month to 3 months to go through this. I don't think we're gonna need that much time, but yeah, I hope you're doing well. Hope your night's going okay over there, or your evening. So we're looking at this one planner problem. Let's see. It is, let me put this in here so everyone can look at it. And there we go. All right. It's number 605. And I have this, and I have, oh, are you serious? All right, hang on. There's a lot of chatter going on. Are busy already today. All right. So I'm theorizing. Let me bring this down. I'm theorizing that this is more of a math, and if we're given, so the premise is we're given an array, they represent flower beds, and they can't be adjacent to each other. So in this one example, we can change this. We can add a flower bed here because we're going to add in flower beds. And then here we're going to add 2 flower beds, which we would need 4. We would need 4 zeros. So now we just have to figure out, do we need 4 zeros or 5 zeros? We need 5 zeros. What would... One, two, three, four, five, six, 7. This is 3, 5, 7. Is this Fibonacci? Because that's 1, 2, 3, 4, 5, 6, 7. And what's 4? One, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 5, 7, 9. All right. Almost looks like an alien. All right. Any questions so far? Array problem? I think so. Hang on. Yeah, we clicked on can place flowers. Yes. String array problem. Yes. Oh, and yes, I think Vanky was pointing out we did do this move zeros problem, but I don't remember, so we may do that again. All right, so so 1 gets us 3, 2 gets us 5, 3 gets us 7, 4 gets us 9. But we need to be able to multiply this. So what's the formula for this? Well, I don't know what that is. 1 times 3 plus 3. All right. Two goes up by 2's. N times 2 plus 1. Is that it? N times 2 plus 1. That feel right? I think so. So all right, let's check this out. So we have to plant flowers in empty plots. And change. Yes, have to be available. So you have to. They can't be adjacent to each other. So that means, Vinky, how are you? I need you to check my math here in a second. All right. So this one right here, we want to add in flowers. So this can be added because we're going to have zeros bordering each of the plots. Now on this one, we cannot add 2 plots because either side we're gonna eat up our adjacents. So Vinky, I was doing some math here. So if we want to add 4, if n is 4, we need 9 zeros. So my gut math, my quick math said it's n times 2 plus 1. Because we need to have a boundary. Now, it may not be exactly right. There may be some bookends, but I think that's it. So we need to do something along the lines of basically. Now we need to look for 0. Okay, so I need hang on, zeros equals n. Ooh. N times 2 plus 1. Times this. Print zeros. Oh, I still got something. Let's comment all this out. And comment. Back down here. All right. And now, if I said 4, that would get me 9 zeros. When zeros. All right. So now... Okay. This is me just shooting in the dark. But I think that's right. Let's go back to this. Let's change this to 1. 1. It can't be this easy, so I have a feeling it's not it. I also want to see... Okay. I could have sworn I checked for patterns. I thought there was a way. That's what I want to do. I want to check for the presence for the list of 9, and I could have sworn I've checked for zeros. I guess we could turn this into a string. So I know you can do that, but it seems like I'm headed down the wrong path. Because what we'd take flower beds. Dot join. If you plant at I minus 1 and I minus 1, yes. Exactly. That is 100% correct. That's my interpretation of this, because each adjacent planter or indices needs to be 0. So basically we can only each indices is a planter, and we need to have a 0 between every one, even if we're going to add in. So there's no way to add. We would need flower bed would need to be one indices longer with another 0 in this group, because we would need to occupy this. And so I at least have, I like this so far. I do not like, this is why I'm not ready for interviews. All right. Is that light still on my face? Because I feel like it is. Yeah. That's so annoying, because I just checked and I thought the sun was up more. All right. I don't need that. I think I have an eyelash in my eye. Okay. And where'd my top go? And Vinky, I don't think you were here. I'm probably gonna. Oh, I just pulled out like 3 eyelashes. Probably gonna cut short about an hour and a half because of I have a dentist appointment, so I gotta move quickly this morning, and try to head to the gym, and then come back and work on my DBT homework. All right. I still have like 2 videos to watch. All right. But I at least did well on last week's homework, so I was pleased about that. All right. We could go through the list one time and count adjacent zeros. Let's do that. Then we only have to iterate through this one time. Hang on. Yeah. For I in flower bed. Count 0. If I equal to 0, then count increment 1. Else count equal 0, print count. Okay, hang on a second. And print count, and then print len zeros equal to count. Wait a second. I need a max count. if count greater than max count, max count equals count, max count. Let's try this. Okay. Don't need that now. So it works. 2 false. All right, there we go. We're getting somewhere. All right, so now let's change this to, oops, 0. Seriously. All right, so now that's 4. This should work. Uh-oh. Okay, I was expecting this to work, zeros, but this is actually correct. Because it needs 5. That's crazy. Okay. I love it when I design, seriously, I love it when I design an algorithm that catches my mistake on the, because we could add 1 there and there. All right, this can't be it. I feel like this is it though. Well, we're gonna find out here in a second. All right. What is this? So I take this, and then I need to do this, and then oh, and this isn't exactly right. I just need len zeros to be greater than or equal to max count. No. All right, hang on. I need len zeros to be less than or equal to, because if I added a bunch of zeros, I should be able to do this. Now, also, what comes to mind about speed is we could stop this here. Yep. Because now we don't have to wait till the end. All right, let's see if we can speed this up. Does that make sense to everyone? So I'm waiting until the end, but if I'm wanting to find this as quickly as possible, I don't need to search, like right here. So I would need to check the rest of the list. I can see Leetcode doing that and differentiating between individuals who realize what the problem is. If count, like we have planted enough. Bingo, exactly. So basically in this, once we find it, we'd stop. And yeah. Exactly. Then we've planted enough. We have enough space, and we don't need it, because I can see Leetcode throwing in a planter with like 1,000,000 zeros, and us checking the entire list of 1,000,000, and you only need to check the first 500,000, because then we're gonna have, because we did run this again, right? The shorter. Oh yeah. Okay. All right. So let's get this. So we added Let's throw this in here and close this down. We need to move this all over, and then we'll speed this up. All right, and now this. What do I want? I don't need to return. If let's just get this to work, and then we'll speed it up, because now I'm concerned about order of operations. All right. I may be completely down the wrong path. This may not work at all. Okay. All right. Oh, yeah, it was just the first two that we checked. Check for this. Okay, let's go back. Vinky's got a great idea. All right. There. One. I think this formula works, but we're going to check it. All right, cool. Because the way that I did the formula, I channeled Vinky right here, because this math. All right, let's see if it passed. No. Aha. Cool. Let's get this over here. This is a good one. All right. So we don't need 3 in this case. You think there's another? I bet there's another one like this. So let's see. Let's clear this. All right, so that one works. That's a good. Oh, that's why I love Leetcode. I guess this is probably also why so many people utilize it. What am I doing now? Yeah, right here. Paste. Let's go a little bit. Let's go. Seriously? Can't go 30, 32? There we go. All right. Here. That's awful. Don't know this side thing that I'm doing. This little loop in. That is so weird. 1, 2, 3, 4, 5. So 0, 0, 1, 0, 1. Trying to think, could we do what is another edge case? Is there another edge case? So if it's 1, we give it 2 zeros. Okay. If n equals 1, zeros, zeros equals else. All right. Let's tweak that again. Throw this against the wall. See what happens. All right. Copy. Paste. I hate it when it does that. All right. See if this passes, because we made a third. All right. On this against the wall. Let's see. Okay. So my premise for my zeros is bad. Oh boy. All right. So we're going to have to. All right. So we're going to have to throw the math away. This is a good one. All right. Math gone. We need to start over. And we need to. Is this a stupid stack problem? This is, or I think it is. So watch me through here. If let's redo this. So if zero, if my end, we need to iterate. So we're going to iterate through the whole list. All right. Getting rid of the math. So math is gone. And we're just going to, look right here, and then we're going to pop our, we're going to decrement in. So basically, can we place a 1? So if, here we go. Check out this design. If index 1 and next index is both 0, decrement 1. Then we check. Okay. All right. Maybe not. Let's see. Because then we'd be here. And because we just. And we look back at 1. All right. So we're going to be constantly look back at 1. Hope I don't get this problem. So if index 0, we're just starting index I. So I and N. There we go. I like Venky's starting with I and N. So if I and I plus 1 are 0, decrement N by 1. All right. So then I move over here. Then I go over, I moves over 1. If previous 0, and this 0, but why wouldn't, okay, maybe not. Why wouldn't, so we'd put this one here. because it would go here, and then this last one. Whoo, this was a good one. Let's come back over here. Did we add this test case? Check out this test case. This thing. Whoa. Copy. Oh, I can. No way. I can actually adjust. That's impressive. All right. We're close on the math. That's kind of cool. Is it a little after 8? It's way after 8. All right, hang on a second. That's so funny. I got funny kids. Have a great day. I've been so tired these days. I think it's stress. Pretty sure it's stress. I don't mind working. I just never know what I'm working is the right stuff. All right. False. And this could go one here and one here. So it broke it up. That's so cool. All right. So let's go through here. If here and here so there's 3 scenarios. Check the yep. If flower I equal to 0, check if the previous and the next are empty. See, I wanted to go decrement in as we placed one. So, and I think there's 2 more scenarios. So that's what is getting us halfway there. Vinky, we need to also have a plan for the beginning and the end. And that's what I think this awesome edge case is, because if it's the end, we can place one there. So I don't know if I've ever checked okay, so index 0. So if index 0 and okay, so there's 3 scenarios. If it's at the end and the one before it is a 0, then we can change it, decrement it. Or if it's index 0 and the next one is 0, and then also 3 at a time. Now we just have to write that. So that's actually the algorithm, I believe. And then we'll be able to test this because we had that fail. We had this fail. Athavard. So that's kind of the premise of one of the things that we've been talking about. So what benefit of changing to Jupyter Notebook would that do? So I'll put that question back on you. What would that accomplish? So, all right. So here we are. Peaky, you still hanging with us? So index 0, index 1. So then while when we get to the end, the current, the previous. Oh. We need to be careful because we need to overwrite it. Because we actually need to change it. Because what could happen is we'd if we're not actually overriding this, we could do this right here. Decrement. Come on. Come on. Decrement, and you can really only put, or would that work? No way. Would that catch itself? Because we could have 2 here, right? Holy moly. Okay, hang on. Because we could change this to 1. Nope. That's just 1. So we need to actually reassign as we're doing this. Because follow me through here. Yeah, like I equals 0 or that's what yep. And I think we could even hard code that and catch that at the beginning. Like if this, change that to 1, if this, change that to 1, and then we start going through like checking all 3 scenarios in one go. I was even thinking we check the first 2, change them, and then when we get to here, because I always freak out when I hear sirens. Let me make sure everybody in my group is stationary. All right, cool. Nobody's driving. So, because I think we literally need to reassign this. So if flower bed, so this is wrong. Is any of this savable? No. All right. This is gone. This is gone. All right. So if flower bed okay, hang on. Hang on. 0 through 0, 1, 2. Check this out. First, I want to make sure that I'm not off in the weeds, and I'm really not. Mm-hmm. Oh. Okay. Flower bed. Right. No, I want this one. And we'll check the next one next. All right. Flower bed. What? Oh. Flower bed 2. Bingo. I love that dude. Cool. All right. Flower bed -1 -1 equal 0. No. 1. Am I really doing this? Sorry, I am giddy that we may have this solved. Okay. And then n minus 1. All right. Okay. Feels while loopy. Or if index peaky, so if n is 3, we need 3 ones. Okay. Now if n is 3, we have a boundary issue. So if we have 3, it's in well, not necessarily. Let's give a scenario. Let's do here. So we can have that be a 1. If it's at an end, it only needs 2 zeros because we're at the end of the row. It just can't be beside a 1. So that can be changed. And this can be changed. So in this one, we could max change 2. And if we were to ask him for 3, that would fail. And if we were to add another 0 right here, 0, comma, don't know why I can't put all my commas right, then I could change 1 more right there. So we literally need to come through and change these. So how am I going to test this? Feels while loopy. So if index 0 and the next one. So we have 3 scenarios. If it's at index 0, that can be 0, and the next one can be 0. Change index 0. So I don't like this setup. I don't like this design. So when we get to index len minus 2. All right. Let's get going through this. We need 1 0 after, well, very, very, very close, Peaky. We need it just, a 1 cannot go the other side of this, reverse that. A 1 can't be beside a 1. So I can put a 1 here, and that would be legal because it's not beside another 1. And it didn't need a third 0 because it's on a boundary. So I can have, what was throwing us off was the end cases. So I was originally just looking at it for a grouping. So there's 3 scenarios. The bookends, the start in the middle. Start in the middle. So we need to elegantly write a scenario where these 2 and these 2. So what I'm doing is I'm like, okay, so when am I going to control getting rid of these? Because while in while n is greater than 0, because while n is greater than 0, check these two. Boom, boom. Then elif. Then I need to for loop here. Because if I do this once, then I don't like how I'm doing this. So while glad everyone's joining today. Everyone do me a favor, if you've not hit the like button, go ahead and do that yet. I'm immersed in this. And sadly, this is an easy one. That is what's throwing me for a pretty big loop on here. Because I love how these are all the same, but they're all not the same. Because, I mean, we got ones and zeros. And we have three different scenarios. All right, let's go back to drawing this out. Scenario 1, I can have 2 zeros at the beginning, 2 zeros at the end. Everything else, I need 3. But as I go through here, I need to change these. Let's just iterate through this. All right, so let's get rid of this garbage. For I in range len flower bed. All right. If I equal to 0, all right, we'll do this. So here's scenario 1. Is index 0. Is our first index 0. If flower bed well, we're already at index 0. So then if flower bed 1, all right, so here we are. And flower bed. Nope. And hang on, sorry. I'm trying to keep this. So we are at index 0. And the element, here we are. Okay. And this flower bed. There we go. And zero, 1, okay. equal to 0, 0. Let's just do pass, so this doesn't throw up. Let's comment this out. All right, flower. Sorry, trying to get this out of my head. I'm on the wrong screen. I can't even see if anyone is asking any questions. Let me get over to chat. There we are. We need 1, 0 for every one. No, that's the interesting scenario. At the bookends, the 0 index, we need 2 zeros, and we can decrement in by 1. And I like the while, because we can do this until, and then I think we're gonna check. at the end of this. But I also like a while. This felt very, very, very wily. But yeah, peaky. We need 3 zeros in the middle, but only 2 zeros on each end. So that's the scenario. So because what we were throwing errors was we weren't catching this one because we can convert this one, and then we weren't catching this one because we can convert this one. Because there is nothing here, so it's basically an empty space, a free space. So we can change this to 1, and there is nothing here, so it's a free spot, an empty spot, however you want to say it. So I want to see this right here for just a second. All right, then I need to flower bed I equals 1, and then in decrement I, or decrement by 1. Then we can safely place a 1 plot. Bingo. I think, hang on, let me reread that. I equals 0, and then we can place a flower at exactly. And then also when we get to in the middle, so that's the bookends. Well, we can place an I here, but then now elif we got to come up with this formula. Because I want to change. All right. Let's bring this one in. We're all over the place. Gee whiz. They are. I do have to say, my jiu-jitsu school, there's some folks in there. They raise a ton of money for charity. There's a young lady who's, man, she's good. She's a purple belt. She's already got, looks like $1,100, and she has to grapple for an hour. And she's like, "Who wants to be my partner?" I'm like, I don't know anybody who could keep up with her for an hour. I actually last month I thought she broke my arm. I thought she broke because I thought my elbow was clear and I thought I was gonna get it down. She's like, okay, and yeah, my elbow was not clear. It was not below her hips, and I thought I was gonna die. It hurt so bad. She's like, "That's on you." I'm like, "Yes, ma'am." So yeah, that was kind of the last cemented thing of you better respect purple belts, because if they're giving you an out, they're trying not to hurt you. Brown belts are even sneakier. All right, so we change that. Then elif I equal to, I don't want to do this len. I don't want to do this len every time. L equals len flower bed. And then we can just change this to L. All right. So I want to know if it's at the end and the end minus 1. L if I is equal to L minus 1 and okay, so flower bed. All right, I want these 3 because I want to be able to test. I want to make sure. Sometimes my negative indexing is not good. So -2 through the end. Let's test this. -3 through the end. Yep. -2. Okay. If we're at the end and flower bed because L is 9, that'll be out of range, so flower bed is 7 through the end. Dax, no worries. We're struggling through the first one today. This one's no joke, and it's easy. So glad to have you, Dax. I hope your day is going well. I'm probably this is gonna be it because we've been on for an hour and 9 minutes. So I need to be wrapping up at about 1:15 because I got a dentist appointment. So we're probably gonna knock this out. Hopefully, get this a little bit better. And that's going to need to be at the end because okay, all right, getting back here. So 8 now minus, what is it, 8? Yeah, it's a 7. I'm just testing. Yep. All right, so and flower bed, we're at the last index. We're gonna need an LF in between. And LF flower bed, we're at index I. Index. We're at the last one, so we're here. Oh, yeah. So index I minus 1 equal to 0. Then flower bed I equals 1. Okay. And then I decrement 1. Minus 1, because I'm looking back here. Because Venki, I'm very hesitant to disagree with you 100%. But we want to look, we're at this last index, and we were looking backwards. Then we're going to change here. That's what this elif is. And why is this not liking this? Oh, flower bed. All right. Now, everything else. I wish there was a better way. It is, I guess it is just elif. So elif I. How can I do this? elif. No way. All right, let's try something. Because what we need to do is I need to bookend. How can I do that? I need a slice. I need to slice this. So let's try something. Flower bed. So let's just pick I. I want to see. Let's change this. I want to see these 3. Yep. Comment that out. All right, cool. I want these 3. And I want to make I 0, 1, 2. So I is 2. I equal to 2. What's the formula to get? Should be I minus 1 through I plus 2. Okay, but this will fail when we get to the end. Nope. When it's the end, you can't be out of range. Bingo. So now let's change. Let's see what happens. Let's make I 0, 1, 2, 3, 4, 5, 6. Okay. I equals 6. Zero, 1, 2, 3, 4, 5, 6. Let's make I 7. I 8. Yep. I 9. Cool. That's our formula. All right. elif. And then each time through, we'll check if I is 0, then we'll stop. And we'll return true. Does that make sense? elif here equal 0, 0, Then flower bed I equals 1. Then in decrement 1. Let's see. Let's see. Can you prepare group Discord for YouTube? Discord is page you want to join. There should be a link in the description below, an invite. So just go down and click that, and you can be over on Discord. So yeah, I have. That's where everyone joins. So let me check and make sure that it is here. Yeah, it's there. Should be ending in BG6Y. So go ahead and jump over there and come and hang out and ask all the questions. So we should be really, really close now, because we want to stop if n equal to 0, then yeah, this should have been a while loop, right? I don't know why I don't default to, even when I felt like it was a while loop, if and then break. And print true, else print false. All right, let's run this bad boy. Get rid of this. That's garbage. This seems overkilly, but I feel pretty comfortable because we covered. So 1, 2. This should return true. Okay. We don't want that. Oh, wait a minute. Okay. False, 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 false. Well, that order of operations is awful. If all right, if n equals 0, break. And print true. That doesn't feel right. That doesn't feel right at all. If we get to the end, here we go. LF n equals 0, and here we go. All right. So if n equals 0, true. LF else false. There we go. Here we go. And great. So if we get to the end, so 9 elif n greater than 1, greater than 0, and I equal to, we're going to change this a little bit, but now I'm already down this rabbit hole. I'm going to change this because we got to change the order of operations with the return, but I want to solve this. So if I is at the end, I is equal to L minus 1. Print false. There. True. So now let's change this to 3. This should be false. Bingo. All right. So now do we have, let's test this, and this is 1. True, and break. That's what I wanted to do. Perfect. Empty plot is 3 zeros, so left and right is 0 is important to check. Yes. So, all right, Peaky, great question. So let's look at this scenario right here. Let's add a 0 and another 0. So this could take 3 right here. So let's actually test this and make sure that our algorithm's working. All right, so let's go through this. So this has two zeros, 2 zeros, 3 zeros. This one right here, you could add 3 ones because this is a boundary. It only needs a 0 in between because there's nothing here. So this is like infinite space. This is the end of the aisle, end of the book, shelf, whatever you want to think about. So we don't need 3 here, nor do we need 3 here, but we do need 3 in the middle because we cannot have 2 ones beside each other. That's the shift that flip your thinking backwards. Don't worry about the zeros, which is where I started. Think about the ones. Ones cannot be adjacent. So that's what we're doing right here. We're checking, and I literally did this in order so my brain could handle it. I'm checking the beginning, that's this scenario, and I'm checking the end, that's this scenario, and then I'm checking everything in the middle. And what I'm doing, can you wrap up all the elifs in one statement? Probably so. Let's see. In one statement, or, and interesting. All right, let's look. Well, no, we have 2 elifs. We have 2 different scenarios. But let's see. Yeah, we probably could because it would be in the middle or the end. And I mean, technically, we could do this really all on one line. So if it's this scenario, actually, I mean, if we really want to do this, we could make this very ugly and put this all on one. Because we're just changing the I. So if it's this scenario, or this scenario, or this scenario, I believe we could technically put this all on one. Because we're not doing different action. Because if we look right here, it's all the same action. If this, you know what? Let's actually try that. It makes it too ugly, in my opinion. Makes it a lot less readable. but technically you can, because, like I said, all same. Let's go back. All same conditions. Because taking I, converting it to a 1, decrementing. Let's comment this out. Because that's everything. Yep, run this. So yes, technically we could do that. I don't like that because it makes it less readable, in my opinion, and I would not be able to think about doing something like that. But again, that's completely legal because, like I said, the instructions are the exact same. But I wanted to clearly, whenever I have scenarios, I like to clearly separate them so I can keep up with them. But yeah, let's test. Let's get rid of this one. This should now become false. And then now we go to 2. This should now become true. All right. So yeah, all right. Well, since we have this working, let's go ahead and place this in, and this is probably be the last. All right, then we're gonna need to tweak our returns. We did this. Copy, paste, copy, paste. Does everyone understand? And we need to tweak this. Oh. Okay. Is that? Wait a minute. That's missing. Oh. That's interesting. I thought we would need to wrap this up, but I want to do that just in case. So I'm missing some parentheses, and that's giving me a panic attack. Hang on one second. Hey. I forgot to say, hey, if it's before 9:30, I might be on my stream still. But are you on your way home?
Yes. You continue your stream. I love you.
I love you too. I'm almost done. We're just wrapping up on one last problem. So you did exactly. You followed the algorithm. If we want to stick to the topic at hand, you stuck to the algorithm perfectly. So thank you very much.
I can help with the lesson. I'll give you a call later today.
Okay, because here everybody, let's just run this. So no, I'm live stream. I'm on right now, and I didn't mute, so everybody gets to hear. And we just failed. So okay, so I need to go and figure out what just failed. But I love you very much, and I will text you when I'm making my eggs, and if that's still a good time, you can call me back. All right. I love you, Nady.
I love you too.
Okay, bye.
Bye.
Sorry about that. I gave my son. I told him what to do today, and didn't think he'd be done with work this morning. He started way early. He opened up the restaurant. All right, so let's see. Return T false, right? So that's what I do like about else. Yeah, I think this is right. I'm worried about. Well, let's just run it. what are we failing here? I'm worried about this order of operate. Let's just get when we get done. I'm worried about having this end before we get to the end, but let's just return n equal to 0. Oh. If n equal 0, break. All right, I'll walk you through why I'm doing that. What? Output true, expected false. No. Output true. How is this? Okay, we need to go back and test over here. Which one was this one? Okay, why? So it's returning that we're writing to 2 of them. So we need to figure out print first. So I'm debugging this. And what I'm doing is it's going through and it's decrementing 2 of them. So I'm finding out what I'm doing right here is I'm finding out which ones are being triggered. All right, we're figuring out why. Second and third. So now, oh yeah, because we're actually changing this. Interesting. So it's triggering. It's triggering. But what did it change? So L is 5, right? I'm not checking this. And oh, I almost did that. Oh. I minus 1 to the end. Okay. False. Boom. Okay. Everyone need me to go back over that? So I got to here and it was triggering this one at the end and I was changing it to a 1. So all right, we need to tweak that a little bit. Yep. Just that simple colon. Isn't that crazy? Just a simple little colon makes all the difference in the world. You serious? Output false. We are testing this last one, 3 and 2. Yeah, it's not an easy one, Peaky. It's not an easy one. This is it's no joke. Even though this is considered an easy one, I disagree. Unless we see the scenario and I got a few more minutes and I absolutely have to go. All right. Copy. And how many into? All right. False. Forgot to check the slice. There we are. We're getting super close. And checking of the slice. And this should do it. Oh, it's comma. Is that what it is? A 35% acceptance rate on this one? This is going to be, whoa. And where did my... No way. And why can't... Where'd my... Okay. All right. I'm losing all my space. So we need to do one for a case with zeros. And where did everything go? All right. I do not have time to fix. I've never understood when you get to something like this. So, all right. Then there's one last scenario. There's one super secret. One super secret one, and we need to... Do not want full screen. This is just getting worse. All right. So I'm gonna go. I've got to keep moving because I got to get out of here in like 25 minutes, and I got a ton to do. So I will see everyone tomorrow. I will have the answer for this. Oh wow, this format. Wow, that is a nice, pretty format. So I'm gonna go. Thank you everyone for being here today. Time to leave. Yep. Time to go. Way past time to go. All right. Thanks, Dax. Thanks, everyone. I will see everyone tomorrow. And I hope everyone has a good rest of their day and a good night. And thanks again, everyone, for joining me. And hopefully that's the last fourth outlier. All right. Thanks, everybody. Bye.